So next semester, we'll take a much deeper dive as to how we modulate cholesterol levels in our body. But one of the ways that you can affect cholesterol levels in your body is your own biosynthesis of cholesterol. Your body can produce cholesterol. Remember, I want you to think about anything that your body produces itself. If it's done in a healthy way, it's probably not that that molecule is bad. There must be something going on that creates a problematic situation. So, in talking about cholesterol, one of the ways that we can modulate the amount of cholesterol that we have in our body is to use drugs called statins that affect your body's ability to produce its own cholesterol. So, I'm going to highlight over here cholesterol, again, is vilified, but it's not really a villain. It is important for so many important functions. And I'm going to walk through some of these here first, and then we're going to talk about how we synthesize cholesterol, which is again a precursor for many of these things, and how and where statins come into play in terms of the cholesterol biosynthesis pathway. So first, let's just sort of talk a little bit about some of the downstream products that use cholesterol as a precursor. Vitamin D is one of them. We're going to talk about vitamin D in our last video here in this learning unit, talking about why vitamin D is important, how it has impacts in sort of calcium homeostasis, okay? But as a short sort of comment here, when we talk about calcium homeostasis, you need to make sure that you have proper levels of calcium in your bloodstream. There's lots of things that calcium are used for. We'll talk about that in our next video, but here's part of the problem. If you have hypercalcemia, you have high levels of blood calcium. That's problematic because your body tries to offload those somewhere. It's going to put them into soft tissues, and that can calcify those. So we'll talk about those problems in our next video here. Again, if you don't have enough calcium, that can lead to problems with the softening of your bones, right? And that's not problem. That's a big problem. So vitamin D, again, a downstream product that uses cholesterol as a precursor. Many of your steroid hormones are synthesized from cholesterol, right? So whether they're your 3 sex hormones, testosterone, estrogen, and progesterone, or your stress hormones like your corticosteroids, you need a healthy level of cholesterol in order to produce these steroid hormones, right? If we look back here at the structure of cholesterol, we have that steroid backbone. And so we can build off of that precursor, that cholesterol precursor, to make a lot of other molecules. Coenzyme Q10, I'm going to highlight that CoQ10 is not made from cholesterol, but statins interfere with the production of a precursor to cholesterol that is also used to make coenzyme Q10. So why is CoQ10 important? It is a critical component of the electron transport chain. So having healthy mitochondria, having healthy energy production in your body is reliant on having sufficient levels of CoQ10. So if you are taking a statin, you really should think about supplementing with coenzyme Q10 because your natural production of CoQ10 is going to be suppressed by a statin. We highlighted the importance of having cholesterol as a lipid bilayer component. About 30% of your lipid bilayer actually has cholesterol embedded, right? We sort of looked at that here in this picture. These are cholesterol molecules that are modulating the fluidity of your membrane. Also, when you have faulty myelin sheaths, that is a function of the autoimmune disease multiple sclerosis. And so having low levels of cholesterol can have a negative impact on that. And the last thing that we've talked about already, but just reiterating this, cholesterol is a necessary precursor to make bile acids. So not only are bile acids the only mechanism for ridding your body of excess cholesterol, but bile acids are necessary for proper fat digestion and absorption in your GI tract, right? You produce these bile acids from cholesterol in your liver, you store them in your gallbladder, they're secreted out into your GI tract, they affect fat digestion and absorption, and many of those bile acids are resorbed from your large intestine, right? But you need to make sure that you are kind of monitoring that effectively so that you don't have a problem with not enough cholesterol resorption or too much cholesterol resorption. Okay, so on the left side here, I want to remind ourselves of some of the things that we've already learned about, and importantly, talk about a branch point metabolite that we call acetyl-CoA. And we haven't really talked much about this molecule before. We learned about it when we talked about our nucleic acid sort of learning unit, because it is a nucleotide derivative. Okay, but it's an important branch point metabolite. And what we do with acetyl-CoA largely has to do with whether we are in a need state or we're in a fed state. So for example, if we are in a need state, okay, what your body can do is it can take acetyl-CoA and it can make it into ketone bodies. And we've talked about the importance of having ketone bodies as a fat-derived but hydrophilic circulating fuel. So to that end, we know that we can take triglycerides and fatty acids and convert them into acetyl-CoA, because then we can generate ketone bodies from that. We also know that we can convert carbohydrates. So carbohydrates specifically, we'll learn about the details of this with glucose metabolism, can be converted into acetyl-CoA. And here again is where this part comes into play, where if we have excess fuel, if we have excess carbohydrates, what's going to happen in your body is you're going to ultimately break those down into acetyl-CoA. Again, if we've got excess acetyl-CoA, what's going to be happening is we'll be in a fed state here. We are going to take and assemble those acetyl-CoA units into triglycerides, and we are then going to store them, right? So important branch point metabolite, acetyl-CoA can be made from excess fat or lipid, right? But importantly, excess carbohydrates converted to acetyl-CoA are reassembled into triglycerides for storage. Okay. Now, why acetyl-CoA is also important to this story is acetyl-CoA is an important precursor for making HMG-CoA. This is the name of something that I want you to know. This is, again, that precursor that's used to make cholesterol. So again, we're going to have HMG-CoA that's going to be made into cholesterol precursors. And again, we can make cholesterol from that. And again, sometimes it's cholesterol, sometimes it's this cholesterol precursor, right? But all of these other pieces that we're talking about here are either made from cholesterol directly or these cholesterol precursors, okay? Another name that I want you to remember is the enzyme that converts HMG-CoA into these cholesterol precursors. It's called HMG-CoA reductase. So two names that I want you to know. We are going to see those several other times throughout the semester here. But why this is important is statins inhibit that enzyme. Statins inhibit HMG-CoA reductase. Okay, so we're going to talk about and use this analogy a lot. When we talk about metabolic pathways, I want you to think about a garden hose. We're going to talk about inactivating or inhibiting any enzyme as pinching the pathway at that point. When we pinch the pathway at this point, we accumulate anything upstream of it. So we're going to have higher levels of anything upstream. We're going to have lower levels of anything that's downstream. So again, HMG-CoA reductase inhibition by statins does exactly what it's supposed to in terms of cholesterol biosynthesis. It decreases cholesterol synthesis. Unfortunately, because cholesterol is a precursor, or some of these cholesterol precursors themselves are precursors for so many of these other things, there's many unintended consequences with statin use. Right? Highlighted that you're not going to be able to produce sufficient levels of coenzyme Q10. You're going to want to supplement with that, right? Steroid hormone synthesis can be affected when you decrease your cholesterol levels. Same thing with vitamin D. So just something to think about. And I do not want you to think that Dr. Parenti is anti-statin. Statins have a very important place in our medical repertoire of tools to sort of help with health and disease. But I do want you to understand how they work. And then importantly, if you are pinching a pathway where you are affecting the production of downstream things, might just be something that you need to think about supplementing.